Good afternoon. Good afternoon. All right, so I know I see some of you on your phones and on your laptops. Are you using Space Cloud? Well, we're going to talk about that today. We're very excited to have this discussion with you. I know there are a lot of engineers, innovators, executives in the room, and we want to make you part of this solution. My name is Yvonne Hodge. I'm the Vice President and CIO for Lockheed Martin Space. And Nikita Patel will be joining me a little later. She's one of our fabulous engineers, new to the company, that's been working this journey around Space Cloud. So first, I think it's important for us to talk about the why. Why Space Cloud? Now, the topic here is, can a cloud in space help solve Earth's biggest challenges and problems? Now, I'm not here to talk to you about and describe to you all the different challenges we have across the humankind. All of you in this room either should know them or should go back and really think about them, learn about them, because we do have challenges as humankind. And space and the information that we're collecting in space can help us solve challenges on Earth. And it's all about the infrastructure and creating that infrastructure that we currently don't have today, but Lockheed Martin, we have a passion naturally as part of the Lockheed Martin Space Business Area, a passion for solving new problems for our customers, and also using innovation and capability and thinking about the art of the possible. I want you to get out of your comfort zones and think out of the box with me as I talk about not just concepts, but what we call pathfinders, or really a journey that we're already on in Lockheed Martin, creating a cloud in space and what that means. So think about it. It's really important that we think about how data is communicated. The essence of any business or any challenge we have, whether it's in our businesses, whether it's in medical, whether it's in terms of our environment, is about getting the information in a timely way and getting it to the right people, getting it so that we can have intelligence that is, I call it the 4 Ps: predictive, proactive, prescriptive, and in my industry, protected, and in many of your industries as well. So we have to consider the 4 Ps in terms of the intelligence that we bring to the table, to the customer, and we need to bring it to the right people on a need-to-know basis. And it has to be fast. It has to be fast. Cloud provides that capability here on Earth. Whether it's in your business, it's changed the way your businesses operate, but it's also changed how you personally operate. Many of you were on your phones before this talk. Hopefully you're not on your phones now, unless you're taking notes. But it's really important that we understand what technologies we can leverage that we're using here on Earth that can help save the future of Earth. And that's what space is all about. It really is. And I think you heard a little bit from this morning from Jeff when he talked about it's about the infrastructure. And that's what we're talking about here today. So I'm here to tell you that Space Cloud, which is a trademark within internal to Lockheed Martin, is not just a concept. We are already working with our engineers and our information technology team that report into my organization to design an in-orbit space cloud using smart satellites, some of which are no bigger than a shoebox, with autonomy, artificial intelligence, machine learning, data analytics, storage, and compute capability. And we are excited. And the kind of things that we call, some people call them experiments. They're more than experiments. We're talking about what we call pathfinders, which is really that journey to the capability actually being launched, and it will be launched in the next 12 months or so, maybe even sooner. And that's what Nikita's going to talk about, is that we're actually coming up with a different approach associated with how do we come up with this innovation. And we're very excited about that. And part of the message I want to provide to you today is that we have an obligation to fill our pipeline with innovative talent. So I want you to meet Danny. I'm not going to give you Danny's last name because I don't want you to go out and try to recruit him. But we do, and I know many of you do STEM events, right? We're trying to encourage our youth to get very excited about capabilities and innovation and learn more about the math and sciences. And my daughter, who's here with me, she actually works with NBA and NFL players as role models to come into events to motivate them that STEM is cool. And so what we did with Danny is that, and a group of 8th graders and 6th graders, is to provide them a journey to Mars using VR and virtual reality and augmented reality. And so Danny is a future Lockheed Martian because he actually journeyed to Mars in VR and AR. That was his reality. It was very interesting talking to him after the event, where he was excited to, well, maybe I want to be an engineer now. Maybe I want to be an astronaut. Maybe I want to personally travel. And in his lifetime, we will be going to Mars. So it was pretty exciting, and I wanted to, this is sort of like a community, public community message, is that we all have to be accountable to motivate the youth of this world in order to become part of the solution. And so I think that's really important. Another tidbit in terms of our journey from the standpoint of deriving a space cloud is that we've been using a lot of virtual reality and augmented reality with our engineers and our operations teams to simulate and really take data and put it into visual capability. So what you just saw was InSight landing on Mars, and this is our Mars base camp. But one of the things that's very interesting, and I want those of you that are doing AI, here you have a simulation of astronauts fixing a problem on the Mars base camp. And what's interesting, if you really study about humans on Mars, the assumption sets change as you write your algorithms for AI. Think about it. Medicine that works on Earth will not work on Mars, right? We've got to have a situation where we've got to design AI so that it's important that they're able to resolve issues much faster than what we probably need to do on Earth, because it's life or death. So here you see they actually high five, so there is a level of celebration when something is fixed. But it's really important that we think about it as we build AI algorithms. And here we have a ship landing from the Mars base camp on Mars and doing testing, because a lot of the experimentation, in fact, I would recommend you go on Instagram and follow InSight. And we built InSight for NASA, so in close partnership, key customer of ours. And then this is a bit of a race that you'll be able to see our people back in our Pulsar incubation and accelerator lab are actually doing this in AR, VR. And when we have people come in, even customers, it's fun to see an executive get on those treadmills and actually do races together. Very competitive, but it's pretty cool. That is not Matt Damon. I just want you to know that's left on Mars. That's not him. In this particular case, that he didn't get left. It was that he's the one that has to do the experiments back on. So it's really, really exciting to use the virtual reality, augmented reality, and we're actually recruiting gamers to come in and be part of that center of excellence within my organization. Now, this is really depicting data. So just think of the particles of data, elements of data that's out there, really. And it's just enormous. And when you think about my background before I came to Lockheed Martin was AT&T, and I helped build this digital infrastructure. And one of the things that customers have been telling us for years and years is about the speed of the data. I need the data. I need it fast. But I'm talking to you more about what cloud does, and what we have to do in space is to convert that data into intelligence. There is so much data that is wasted. I mean, we've got, Lockheed Martin has launched 500 satellites. Just Lockheed Martin has launched 500 satellites. And they're huge in some cases, in many cases, some of which I could talk about, many of which I can't. But it's all about the data. And in this model, what we're showing here is more, we've had a journey of terrestrial connectivity. But what we really want to think about is how do we bring that information back to Earth, also Earth to Mars, Earth to the Moon. And like I said, the cloud-based technology will do that. So think about it. Artificial intelligence, we need to think about those algorithms differently. I don't know if many of you know this, but in terms of, just think about medical information. And when you build algorithms associated with fixing problems, you have to think about differently that when you're on Mars or really in space, fluids tend to go to your brain, which doesn't happen here, hopefully, and because of the gravity levels, right? But that actually throws off your equilibrium, your vision. So that's an example of where you've got to change basically your frame of reference and your thought process and think about how your variables really change as a result of how you build AI. When I was a deep thinker, I'm a mathematician by education, and I was always fascinated with ring theory. Do I have any mathematicians in here? Okay, so I know you know ring theory. But it's the aspect of that, basically multiplication changes depending on what kind of ring you're in. So A times B does not necessarily equal B times A, depending on the ring. I want you to think of that there are some rings that are very unpredictable. Think about that from a space perspective. So what I might do is do a 6-pager, that's Amazon, people know what a 6-pager is, or what we call a white paper on that theory. It would be pretty cool. All right, so I'd like to introduce to you Nikita. She's going to talk about some of the work that her and her peers have been doing around space cloud.
Hello, everyone. My name is Nikita, like Yvonne mentioned. I'm a software engineer at Lockheed Martin. So I'm going to start off by kind of just giving you an idea of where space is at for people who aren't working in space every day like I am. So these blue dots here, they actually represent our satellites in lower Earth orbit, our LEO birds. So relatively, these are the closest satellites we have to the surface, anywhere from 100 miles to 1,000 miles in altitude. And they have high bandwidth and low latency because of their relative distance. And this is where most of our imagery satellites live. So for people who use Google Earth, this is where you get your images from. So these green dots here, there are satellites in middle Earth orbit, or MEO birds. So here, your satellites are slightly farther. The range is larger. It's anywhere from 1,000 miles to 22,000 miles from the surface. And they require a lot more energy to get their data back to Earth. They have slightly higher latency, but you get wider coverage. So normally GPS satellites will live in MEO. These pink dots here are your geosynchronous orbit satellites. They are geostationary. They watch over the same large swath of area at all times, and they gather tons and tons of data. But it takes a lot of energy to get all that data back to the ground for people to use. That's why these satellites are usually ginormous. I call them our behemoth birds. These are anywhere from 22,000 miles onward from the surface. Right now, these satellites don't really communicate with each other. What they do is they collect all their data and they dump it back to Earth for someone on the ground to parse through that information, analyze, and kind of extract what they want from it. So what if instead of gathering data in space and sending it back to Earth, we were taking data from Earth and sending it outwards? That could be to the moon, that could be to Mars, honestly anywhere. So we can actually enable this if we have the right infrastructure. And it would really only require 1 meter wide mirrors, laser comms, laser comms and strategically placed relay devices at various Lagrange points. And that's all we need, and we can ensure continuous gigabit per second connection from Earth to anywhere. But that infrastructure doesn't exist right now. If we wanted to put this infrastructure in place and solve the problems of the future, how are we going to do that? So Lockheed Martin, what we do is we have something called the Neutron Innovation Incubator. So I was lucky enough to be part of iteration 0 before it even had a name, and it was just an experiment. So we were just a group of 10 kids straight out of college who didn't know anything about anything, and we had these experts come to us with an abstract concept, and they kind of just said, this is what we want, run with it, have some fun. Which all that creative freedom is amazing, but when you don't know anything about anything, or at least you don't think you do, it's really, really intimidating. But we were lucky enough to have LM Fellows as our mentors with decades of experience and expertise in the areas we were researching, and they served as hands-off mentors. They were very, very careful to give us guidance, but they never gave us direction. They never pushed us one way or the other, even if they knew better and even if they knew what we were trying wasn't going to be totally successful in the end. And that allowed us to be self-organizing, self-tasking, allowed us to explore, innovate, and most importantly, allowed us to fail and learn from those failures. So what came of this? What was the point, right? You take 10 kids and you tell them to do something. Did anything come of that? So I was actually part of the team called HiveStar, and what we created was a hive, or a constellation of heterogeneous nodes that were self-organizing and self-tasking, much like our team. And these nodes take a mission and collectively perform it. So these nodes were, our hive actually was decentralized, software-defined, resilient, modular, and masterless. And we designed our entire architecture around these principles. We wanted to test these on satellites. We wanted to just put our architecture on satellites and do it, but Yvonne's team wasn't too okay with that off the bat. So instead, they gave us some pretty cool drones to work with. But like I mentioned, this hive is heterogeneous, right? It doesn't need to just be drones. It could be satellites in GEO, MEO, and LEO with different sensors in different orbits performing different tasks, but they talk to each other, right? Or in the spirit of going to Mars, it could be a combination of satellites orbiting Mars and drones flying through its atmosphere, rovers on the ground collecting data, all combining that knowledge and giving the user back information. So how did this hive work? Essentially, the user gives the hive a task or a mission. The hive collectively decides how they're going to best perform that mission, goes out, collects its data. And then this is the important part. They take that data and they analyze it themselves, giving the user back exactly what they want. We are not doing massive data dumps like right now we do in space. Instead, we're taking that data and giving back the user valuable information. So my team was actually able to do this within about 6 months. We got the main architecture and the principles down and demoed it to our VPs using drones. And this honestly would not have been possible without the Innovation Incubator and Yvonne's team's trust in us. It was a perfect mixture of creative freedom, support, trust, and hands-off guidance. They gave us newly minted engineers the opportunity to take an abstract concept and bring it to fruition however we saw fit. And it inspires me because I got to work on the kind of stuff I became an engineer to do anyways. I didn't sit behind a desk and kind of perform tasks. I got to take something from 0 to 100. And it was super valuable. It gave us great exposure. And this is how Lockheed Martin is developing its future leaders. We're taking this exposure, these things that we learned, the failures that we had, and we're taking it to other parts of our business. And if nothing else, we got to play with some pretty cool drones.
She's not releasable. I just want you to know if you try to recruit her. But I thought it would be good for you to hear it straight from Nikita, the energy level she has associated with what they did as a team and what they're still working on. You know, the design that they've come up with is really software-defined. We think about software-defined anything, and from that perspective, the resiliency is awesome. I mean, because one of the things that keeps me up at night, during the media roundtable last night, I was asked that question, and one is cyber. And so the resiliency and being able to protect the information and our assets is really critical. So great job by the team. So just to kind of, we only have about 8 minutes. That's the image of a cloud, so to speak, but which it won't look like that. But really, one of the key things about the HiveStar that she was talking about is that we're not talking about just launching small smart sats to operate in a hive. It's also the aspect of dealing with and interacting and communicating with the current base of satellites that are already up there. And that's really important, and you can see this image the way we've got it. This is another version of what the hive would look like. But what's very different is the point that Nikita was making. It's not just about collecting the data and then sending it back to the ground for processing and analysis. It's about analyzing the information in space, and what this is depicting is sending the knowledge, the intelligence back to Earth. Think about it from this perspective. Our satellites, one of the key areas of our satellites is weather prediction and information. So think about firefighters, right? Terrible forest fires and situations that we have here on Earth, recently California, and being able to send information to the firefighters about predicting implications of weather situations that could actually make the situation much worse. Those are the kind of things that we'll still need to do on Mars or the Moon. We're actually, if you go on Insight, the Instagram, we now are discovering Mars quakes, right? Can't call them earthquakes, but Mars quakes, or Mars storms, and situations like that. And we're learning so much in space that we want to make sure that that helps us to survive here on Earth. And that's the key point here. So just to kind of summarize, and we have probably 5 minutes left for maybe a question or two, but this is really depicting that it's really all about the data. I know many of you are hiring chief data officers. What I would like to encourage you to do is really think about your data architectures, your data integrity, what elements of data do you need and what should you be getting access to, even just strictly from the standpoint of how you're running your businesses. So just before we talked about Space Cloud, just talking about data access and making sure that you're writing the right algorithms for your artificial intelligence, and encouraging your talent to come up and think, with ideas and innovations out of the box. But when you really talk about, and all of you in here are somewhat interested in space, I think you all have a passion, I'm going to assume that, or you wouldn't be sitting here. Think about the art of the possible around how awesome it is to think about learning about what we don't know. We talk about here in business that we don't know what we don't know, so we do have different approaches to study that. But imagine that in space, especially if you're talking about deep space. By definition, we don't know what we don't know. That's the reality of space. And so we have to be hungry to capture that information and analyze it and get it to the right people at the right time in an agile approach. But in order to do that, it can't be just data flowing back to Earth. It has to be analyzed within the Earth. I would offer, my email is yvonne.o.hodge@lmco.com. If any of you are interested in your companies in doing a think time with us to kind of brainstorm ideas, more than happy to invite you to Colorado. We're actually outside of Denver in Waterton. That's the Neutron and Pulsar location that we built for accelerating learning and also doing analysis of technology. And that's where the team is writing the software for the drone team that Nikita talked about. We're actually flying that. And so we're pretty excited about that. But a think time across companies would be awesome. And so we would invite you to participate in that. And that's our story. So welcome to Space Cloud. Those of you who use your phones, I'm sure you'll get some information if you do 1-800 Yvonne Hodge Space Cloud. So just kidding, just kidding. So are there any questions? We have about 3. Oh.